Okay, this is the solutions video for the self-assessment quiz 5.3 and 5.6. When does a function not have an inverse function? Well, that means it failed the horizontal line test. But what does that mean if it fails the horizontal line test? Well, let's talk about what that means. So, fails horizontal line test. And what that means is when two or more different inputs, x values, right, have the same output. Well, that's actually the best way to answer that question, but it fails a horizontal line test. But what that means is two or more inputs, x values have the same output. All right, 2, if the function has an inverse function, find its inverse function and note any domain constraints on the inverse function. All right, so really it's best if you sketch the original function. So this is a square root function. It has an x-axis reflection shifted to the left 8, down 10. So it looks maybe something like this. And that would be at -8 comma -10. And the domain is x has to be greater than or equal to -8. And the range y has to be less than or equal to -10. Now, it does pass the horizontal line test. We are going to switch our x's and y's. We can think of f of x as a y, and we get x equals negative square root of y plus 8 minus 10. We will add 10 to both sides, equals negative square root of 8x plus 8. I will multiply both sides by -1, and I get x plus 10 equals, oh, I lost my y. Where'd my y go? This is y. Square root of, I got rid of my negative. Okay, square root of y plus 8. Now I need to square both sides to undo the radical sign. And on the left side, I take negative squared is a positive, and then I have left x plus 10 squared. And then I get y plus 8 on the right. I need to subtract 8, and I will find y to be equal to x plus 10 squared minus 8. Okay. Let's see. That is the inverse function of x, and that is x plus 10 squared minus 8. That's the proper syntax. And we also have to note the domain constraints. The domain constraints were my previous range constraints. And so that will be x has to be less than or equal to -10. And if we wanted to quick sketch that, it's a parabola that is shifted to the left 10, down 8. So it might be something like, I don't know, we'll call it there. And it's only graphing the left side of it, so it'll look something like this. And even though this is rather crude, hopefully you see that that's a reflection on the y equals x line. This is the answer. That graph was not required. Okay. B, I have been given the original function. It is a parabola that has an x-axis reflection and has been shifted up 12. However, we're only graphing the left-hand side of it. That's probably a little bit, yeah, there we go. All right, so that point right there is at 0, 12. Okay, let's see if we can make it so you can read it. 0, 12. There we go. All right. And it does pass the horizontal line test. And now I need to solve for my inverse function. So we will say x is equal to negative y squared plus 12. We will solve for y. X minus 12 equals negative y squared. We will multiply both sides by -1. And we'll get x minus 12 equals y squared. And now I need to take the square root, which is plus or minus. Don't forget that. And I will find that y is equal to plus or minus the square root of negative x minus 12. Okay, now we have to decide what branch. We have to evaluate the original equations, domain and range. The domain for the original equation they gave us, x is less than or equal to 0, and the range, y, is less than or equal to 12. So I have to evaluate the domain from the original equation, which says it has to be less than or equal to 0. So I need the negative branch of that. And so I find the inverse function to equal the negative of the square root of negative x minus 12. The domain will be what was the range, and that will be x is less than or equal to 12. So if I wanted to graph that quickly, I would graph the square root function that has been reflected across the x-axis and the y-axis and has been shifted to the right 12. So maybe we'll say there, that's at x is at 12, 0, and it has a x-axis, y-axis reflection. And even though it's a crude sketch, you hopefully can see it's a reflection across the y equals x line. But this is my answer. Okay. All right, C. I have a parent function that is a square root function that has been shifted to the right A units and up B. So we'll say this is at point AB. And it might look something, I know it has a vertical dilation, but we will assume we don't know which one's higher, so I'm not sure how we would know. Difficult to sketch when you don't know the values of A and B. Hold on, let me look at the instructions. Well, all we know is A and B are positive. So up A, B, square root. All we know this is A and B. The domain, which is x's, has to be greater than or equal to A. Range, which are y's, has to be greater than or equal to B. We will solve for our inverse function. So x is equal to 1/3 square root of y minus a plus b. The reason why he's doing this with a's and b's is to give you practice, since we probably will have a test that has some a's and b's in there to prevent photo math. All right, so now what do we have to do? That's 1/3, not 1/2. Okay, so now I've moved my b over. I now need to multiply both sides by 3. I get x minus b times 3, and then I get the square root of y minus a. Need to square the both sides. 3 squared is 9, and then it's multiplied times x minus b squared, and then I get y minus a. I get y is equal to 9 times x minus b squared plus a. That is my function. I've been asked, we'll put it in correct syntax, and that will be 9 times x minus b squared plus a. And then I have to provide my domain constraints, which are what used to be my range constraints. So x has to be greater than or equal to b. All right, D. Here's my sketch of my original graph. It's a parabola. It's been shifted to the right 3, up 4b. So we'll call it 3, 4b. And we notice that we're only graphing the right side of it because x has to be greater than or equal to 3. So maybe something like that. So the domain is x greater than or equal to 3, and range is y is greater than or equal to, oops, excuse me, 4b. Now I have to solve for my inverse function, which is y minus 3 squared plus 4b is equal to x. Solve for y. So x minus 4b is equal to y minus 3 squared. I got to take the square root of both sides. There'll be a plus or minus. I will find plus or minus the square root of 4 minus, I'm sorry, getting tired, x minus 4b is equal to y minus 3. Going to add 3 to both sides. And we have x minus 4b plus 3. Now, which do I need? I need the positive branch or the negative branch. The domain from the previous problem is my new range, and it will be greater than or equal to 3, so I need the positive branch of that. So the inverse function of x is equal to the square root of x minus 4b plus 3. And then my domain was my original range, and I get x has to be greater than or equal to 4b. And there is your answer. All right, moving on. Given the function f of x, find its inverse function graphically and identify the domain and range of both functions and the inverse function. I'll start with this point here. That is at negative 3, 4. I need to draw that at 4, negative 3. So I go there, I will draw a circle that is at 4, negative 3. Then I'm going to look at this endpoint right there that's in blue. That is at 1, 3. So I need to go to 3, 1. And I will place that point there, and then I'll draw that line segment, and I'm moving on to the next point. This point right here is at 3, negative 1. So I need to go to negative 1, 3. I'll be right there, and I'll connect that line point. And hopefully you can see that that is a reflection in the y equals x line. The domain of my original function started at negative 3 all the way to positive 3, except it didn't include negative 3. So we'll have a parentheses, goes up to positive 3, and it does include it because it's a solid circle, and that's why it's a bracket. My range of the original function started at negative 1 and went all the way up to positive 4. Didn't include positive 4, however. So negative 1 needs to be bracketed because it included it, and comma up to positive 4, and it's a parentheses, which does not include it. The domain of the inverse function becomes the range, or was the range of my original function. So that will be negative 1, 4, and the range was originally the domain. And hopefully you can see that on the graph by looking at the inverse function and seeing that these actually match. Okay. Solve the radical equation or inequality and assume that the constants a and b are positive. So the first thing we need to do is isolate the radical by itself. So we're going to add 2 to both sides, and 6 plus 2 is 8. And then we will divide by a, and we will then square both sides. and we'll get x plus b is equal to 64 over a squared, and then we will subtract b. And we will then take this answer and confirm that it is an actual solution by plugging that answer into x. So if I take 64a squared minus b and then add b, so b's cancel, then I take the square root of 64 over a squared, I get 8 over a squared. A's cancel, I get 8 minus 2, that's 6, so that checks out. So this is a solution. All right, B. I need to get the radical by itself. I'm going to subtract a from both sides. I will then multiply both sides by -1. And when I do that, oops, I need to switch the sign. So that will become less than, and that will be a positive a minus 4. Okay, then I need to square both sides. And I get x is less than a minus 4 squared. This is an inequality, so we have to evaluate the domain of the original. And so what is the domain of the original? X has to be greater than or equal to 0. So I need to combine these two. And what do I get? I find that 0 is less than or equal to x, and x is less than a minus 4 squared. And that is the answer to this problem. Okay. They've already got this first radical isolated, so we'll square both sides. We get x minus 7 equals 9 minus 6. I'm gonna do that in my head quick. Yeah, 6 square root of x, and then we're foiling that, and I'll get a positive x. Yes. All right, so I got to subtract 9, subtract x from both sides, and I get negative 16 is equal to a negative 6 square root of x. Divide both sides by negative 6. I get a positive 16 over 6 equals the square root of x. I can simplify that. That'll give me 8 over 3 equals the square root of x. Now I can square both sides, and I find that x is equal to 64 over 9. Now I have to check. I have to actually put this value into both of these and confirm that I have a true solution. So let's check the first one. So I take the square root of 64 over 9 minus, got to find a common denominator. So we'll multiply 7 by 9 and we'll get 63 over 9. And that will give me the square root of 1 over 9, which will give me 1/3. And then we'll check the right-hand side of the equation, and we will find that 3 minus the square root of 64 over 9, which will give you 3 minus 8 over 3. We will have to find a common denominator. So 3 times 3 is 9 over 3 minus 8. That gives me 1/3. Sure enough, they equal one another. So this is a solution. Letter D, that is, we need to get the radical by itself. And so we'll subtract 10, that would have given me 2 over there. And then I need to square both sides. And I get 2x minus 4 is less than or equal to 4. I will then add 4 and divide by 2, and I get less than or equal to 4. Okay, now this is an inequality, and I have this under an even radical, so I have to find my original domain constraints, not less than, it's got to be greater than. It's got to be greater than or equal to 0. And we find that x has to be greater than or equal to 2. So I need to combine those two. So we're going to take this domain and this solution and combine it, and we will find that 2 is less than or equal to x, which is less than or equal to 4. And there is your solution to D. I hope that solution video helped, and that you're getting ready for your test tomorrow. Or actually, no, 2 more days.